Whoa, here we are. It's the next lesson already. Check it out. We're going to talk about RAM. What? Yes. Come on, let's get into it. So we've got server RAM, right? So it's the abbreviation of random access memory. You probably know that. But it's also called server memory. It's processing data from hard disk drives or solid state drives to the CPU. So in fact, server RAM is volatile memory, not permanent storage memory, which means it only holds data when it's connected to a power source. Hence, hard disk drives are used to store data permanently, right? However, the read-write speed of RAM is way faster than storage memory. The CPU can go directly to server RAM without searching the hard drive for data or instructions. Now, besides all that, server memory also generates less heat and is less prone to wearing out over time. Now, normally, the capacity of RAM is regarded as a vital factor affecting system performance. Running out of server memory may lead to bottlenecks that affect the efficiency of the server system. So with more memory, a server can run more virtual machines, or VMs. In fact, upgrading the existing server memory can improve memory speed and bandwidth for faster data processing. Okay, so now you know server memory is random access memory known as RAM, which processes data from HDDs to the CPU. As a form of volatile memory, when server memory is powered off, it's going to lose all its held information, right? So one way to think about it is that your RAM modules are short-term memory, and your HDDs are long-term memory. So if you already have this long-term memory, why bother using short-term memory? Well, the answer is because RAM is so much faster than non-volatile memory. So rather than searching all over for data or instructions in the hard drive, the CPU can bypass this slower storage and go straight to the server memory. So that enables better read times in your server. By adding more memory or by increasing memory speed and bandwidth, servers will be able to handle more virtual machines or VMs and distribute their loads more effectively, helping businesses to run more efficiently. So if memory fails, well, it can result in data loss and server faults that can lead to lengthy periods of downtime and loss of production. So if you think of your RAM memory like a desk or a workbench, RAM is almost always being used by your computer or system to allow a variety of projects to work on all at once. So the bigger your desk, the more tasks you're able to complete. And if you're like me, the more things you have on your desk, the more likely you are to find everything. No, okay, so that's where the analogy might break down, but you know what I'm saying. All right, so let's talk about server RAM types. So typically, we've got two main types of server RAM, buffered memory and unbuffered memory. So the major difference between these two types of RAM is buffered memory contains registers between dynamic random access memory modules and the memory controller, where you're not going to get any of that with unbuffered memory. Yeah, let's detail it. So buffered memory, also called registered memory. This is used to reduce electrical load on the memory controller. Besides, buffered RAM is usually used for servers and other high-end systems that need a stable operating environment because it has high stability and stored data. So the biggest advantage of buffered RAM is the buffer, which can receive information directly from the CPU, thus reducing actual physical read and write times. But guess what? We're going to break it down even further because there are three different types of buffered memory. So we've got registered memory, RDIMM, local reduced memory, LRDIMM, and fully buffered memory, or FBDIMM. RDIMM. So unlike unbuffered memory, registered memory contains registers on the DIMM to buffer command signals between DRAMs and the memory controller, right? So this allows the use of up to 3 dual-rank DIMMs per memory channel. Thus, increasing the amount of memory that the server can support. Okay, LRDIMM. This is a newer version of buffered memory. LRDIMM provides large overall maximum memory capacity since it makes use of the memory buffer to integrate the electrical loads on the ranks of the LRDIMMs into a single electrical load. You see that? Now check it out. It also generates more power and has lower latency compared to RDIMM. FBDIMM is an older version of buffered memory, which is also a RAM production technology. So it's used to improve the speed, stability, and compatibility of server memory to the greatest extent. FBDIMMs and LRDIMMs are not compatible with RDIMM, and they're used to reduce the load on the memory bus by the memory modules. Okay, you asked for it, you got it. In unbuffered memory, the CPU will directly access a memory controller, since there is no register between DRAM modules and the memory controller. Okay. Different, though, from buffered memory, it will generate more electrical load on the memory controller. So unbuffered RAM is commonly used for desktops and laptops because of its relatively low price. However, of course, it would be less stable for system and stored data. So what are these server RAM technologies? Well, the reason server RAM outperforms PC RAM is its unique technologies, such as ECC, chip kill, and register, which provide extremely high stability and error correction performance for server RAM. Yeah, you heard me. Error checking and correcting. ECC. So it's an error correction technique in computer instructions widely used in a variety of fields, actually. Compared to parity, an error-checking technology used in ordinary server memory, ECC technology can not only check for errors, but also correct them. Yeah, because due to electrical factors, the data transferred in server memory cannot be completely accurate. But with ECC memory, the stability and reliability of server system can be guaranteed. Register is another technology widely used in server RAM. But actually, registers are to the server memory what directories are to books. Yeah, with a register, after receiving instructions, the server memory can retrieve the directory first and then perform read and write operations. So you see, by doing that, the working efficiency of server RAM will be greatly increased. And what's more, currently popular register memory is also equipped with ECC technology. So that is called ECC registered memory. So these two will always complement each other. I mentioned chip kill memory earlier. I wonder if you are aware that chip kill memory technology was developed by IBM 20 years ago. They thought it would be a great way to solve the shortage of ECC technology in server memory. So it's actually a new ECC memory protection standard. Since ECC cannot correct errors of more than 2 bits, all bits of data will be likely to get lost, resulting in system crashes. However, data can be written to multiple DIMM memory chips via chip kill technology, which means that if any one of the chips fails, it affects a certain bit of a data byte rather than the normal operation of servers. So in addition, with chip kill memory technology, server memory can check and fix up to 4 bad data bits at the same time, further improving the server usability. Memory mirroring is a technique that divides server memory into 2 independent channels. Now, typically, one channel replicates another for redundancy. So, for instance, if a DIMM fails, the entire server system won't be affected because the memory controllers immediately move to another channel. Therefore, with memory mirroring, a higher level of memory reliability and consolidation can be achieved. Besides, it also provides comprehensive protection against single-bit and multiple-bit errors. So just as this name would imply, memory protection is a strategy that controls the amount of memory access rights on a computer. The main purpose of it is to prevent applications from taking advantage of memory that systems have not allocated, which can avoid damage or even data loss to some extent. Similar to the hot backup of hard disks, memory protection technology can use the spare bits to retrieve data when the DIMM fails, thus ensuring the smooth operation of the server. It can also correct up to 4 consecutive bit errors in each pair of DIMMs. All right, so we're going to wrap up our lesson here. Now you know about RAM and server RAM. So thanks for hanging in there. Check out the next video, though. We've got more in store.